This is the setup of our experiment. This is our light source. We use hydrogen. And this is the spectrometer. Here, I want to show you how to do the calibration and how to optimize all the resolution. First, this is the collimator. We have a gauge or a slit which you can adjust with this knob. Now, I will first remove the grating. Through the telescope, you can find the image of the gauge or the slit here. Now, if you look at through the microscope and make your slit at the center of the cross, now you can adjust the width of the slit. Okay. You want to adjust the width of the slit not too wide. The wider the slit, you will get more light passing through. It means you have a higher intensity. However, the theory of the optics shows the wider the slit, you will lower the resolution. It means you will find very difficult to distinguish between two lines that are very close. Next, we want to optimize the setting. Let's have a look what we can control. We can control the width of the slit with this knob. We can also control the optics with this one. Now, if you hold this one down or with your partner, you see you can pull this one, so you're changing the focus. Here, this is the telescope. You can also change the focus. And you can rotate this part. This we call the objective, and this is the eyepiece. Now, the main thing about calibration is we want the beam or the light, when it hits the grating, they are parallel. So you see the image doesn't mean it's parallel. So how do we ensure it's parallel? We rotate your telescope and we try to find any object. Ideally, you should find an object which is sitting at infinitive. Now, we are doing our laboratory in the lab, so we cannot easily find an object which is at infinitive. You don't need to bring this one to the window, and sometime in another lab I will. So all you need is try to find any object or the button where close to the door. Now you look through your telescope and you try to focus this object. Now remember the theory of the optics. If you see an object which is in focus and the object is sitting at infinitive, it means the light coming through here, they are parallel. So at this stage, the telescope setting is optimized for parallel light, and you don't want to change it from now on. So it means whenever you see anything in focus or clear through the telescope, it means the light coming into it, they are in parallel. Now we rotate this one back and align this one to the collimator and put your crosshair. Now you put your crosshair at the center of the slit. Next, you rotate this one. Make sure you hold this one firm. Now you can rotate this one. You can see sometimes you can change how clear you see the slit. Now, when I say clear, you are looking at the edge of the gauge. It means if this is the edge of the gauge you see, you want to make the edge in focus. So you rotate this one and you can see a little bit dust sometimes, very close at the edge. Now, once this one, the edge of the gauge or the slit is in focus, what it means? It means now the light at this path, they are parallel. So it means now the optics is optimized. Next, you put your diffraction grating at the table. Now, this table has been calibrated, which ensures this is level. Sometimes, when you rotate your telescope to your left-hand side or to your right-hand side, if you see the line, they are tilted. It means it's one side high, one side down. Very likely, your grating is not exactly level or square, vertically put at this level. In this case, you should ask the technician or your teacher. They will help to level this one. The process is very complicated. It's not easy. So one thing, do not change all the screw here, this one, and this one, because they will level the table. When you look into your telescope and start finding the spectral light coming from the hydrogen, you have to switch off the light. Assume the light is switched off. Now we start our experiment. First, we make sure the crosshair is put right at the middle of the slits. And now you want to read what is the angle here. I can read from here, the angle is 24.0 degree. Later, I'm going to show you how to read this one with so-called the vernier scale. Next, you rotate your telescope either to the right or to the left. And you keep rotating until you find the violet line. Once you find the line, you read the angle. So what we want is the angle of the line diffracted by the diffraction grating. So you first read the angle here, 24.0 degree, and then you read another angle on the scale, on the table here. The difference is the angle which this particular line diffracted by the diffraction grating. You keep going. After you finish the first line, you search for the second line and the third line.